clock has started. Roger, 0G, I feel fine. Godspeed, John Glenn. Houston, Tranquility Base here. The Eagle has landed. Roger, Tranquility, we copy you on the ground. New possibilities are opening up for scientific cooperation between countries. 1, 0, 0. Liftoff. Americans return to space as Discovery clears the tower. Discovery, go and throttle up. Discovery, Roger, go for deploy.
Thanks to you and to everybody in the shuttle program. The crew is go for launch.
Roger, nice to be in orbit.
We have followed in their footsteps to get us where we are today.
Good morning and welcome back to NASA's Johnson Space Center in Houston for a second in a series of 3 briefings today, all talking about NASA's Boeing Crew flight test. This mission is a flight test of the Boeing Starliner spacecraft scheduled to launch in early May with our 2 NASA astronauts, Sunny Williams and Butch Wilmore. Our briefing today will focus on the details of that mission. Our guests here with us today will discuss the timeline and all phases of flight that they'll be keeping an eye on. Here with us today we have Mike Lammers, Starliner Ascent Flight Director, Ed Van Cise, Starliner Rendezvous Flight Director, and Vincent LaCourt, International Space Station Flight Director. We'll be taking some questions here in the room, on the phone, and on social media. If you're joining us from the phone bridge, please press *1 to enter our question queue. And on social media, if you have a question, please use hashtag #AskNASA. When you're asking your question, please state your name and media affiliation, as well as who you would like to address your question to. But first, we're going to start off with some opening remarks. I'll kick it off with Mike Lammers.
Okay, thank you, Chelsea. Again, I'm Mike Lammers. I've been a flight director in Houston for about 15 years on a number of programs, but today I'm kind of excited to come talk to you as the Starliner flight director. I'm the lead flight director, and I also do the ascent phase of the flight. And in that role, I lead the Boeing and ULA, United Launch Alliance operations team that gets the crew both into the vehicle pre-launch as well as gets them into space. And it's been a culmination of a number of years of developing how this flight system works with Boeing and United Launch Alliance, as well as developing procedures, operation techniques, and training, especially here at the end where we go through a lot of the details of the mission. And it's really just outstanding to talk to you about it, and I know we're all really excited to get into the details of the mission. Just up top, again, we're targeting launch to be early May, and we will have a rendezvous 24 hours later, and we're going to do a minimum of an 8-day mission and test flight. And I stress it's a test flight, right? The mission is to shake down the vehicle with the crew on board. We've flown it twice before, but this will be the first time with the crew when we want to learn about it and make it available as a tool to transport crew up and down to the International Space Station. Again, it's targeting a minimum of an 8-day mission, but the total length is going to be defined by orbital mechanics and the weather at our landing locations, which are in the Southwest United States. I'll talk about that in a little bit. Again, I'm here with Ed and Vincent. What we're going to do is we'll talk about each phase of flight. I'll start with ascent. Ed will go into the rendezvous. Vincent will talk about what we're doing docked. Then I'll hand back over to me. I'll go through kind of the landing phase, and then we'll get into questions. Again, real happy to go into all sorts of detail. We live and breathe this stuff. So if you have any questions or things that you want more amplification on, we're more than happy to go into that. So what I'll do is I'll talk verbally a little bit before we go into the video, but I'm going to start with the day before launch. The way this system works is the vehicle is going to be stacked on the Atlas V at what we call the VIF, the Vertical Integration Facility, I believe that stands for, out at Pad 41. And the day before launch in the morning, the stack will be rolled out to the launch pad, brought down hard on the launch pad, and they'll do some checkouts. And then we have a Boeing team in Florida at the Boeing BMCC, Boeing Mission Control Center. They actually they're the team of engineers and technicians that do all the integration and test of the spacecraft. They power up the spacecraft, power it up and down all the time. In fact, just over these last few days, they've been doing that to fuel the spacecraft. They will power up the spacecraft. My team in Houston will come on and watch with that, as well as the Boeing engineering team that's based in Houston will be right down the hall from me. And we'll bring the vehicle up, we'll do some checkouts, we'll make sure it can communicate through TDRS and the communications network, and do some file uplinks to the vehicle, and just generally make sure it's ready for launch. The next day we'll also do a briefing for the crew, just to give them any last minute things that may have come up, and kind of a look at the weather. What we're going to do on launch day is Butch and Sunny will wake up on launch day, go through some of their preliminary activities. They're turned over to Boeing at about 4.5 hours before flight, right? Then Boeing manages all the crew activities, both to get them ready and out to the pad. At that time, we'll do basically a weather check with the crew. I'll run a weather briefing with them, and then they'll go ahead and go into the suit room and get suited up with the Boeing and David Clark technicians that do that. As the crew is getting ready, the Boeing team in Florida will do the final activation of the spacecraft, and that involves bringing the propulsion system up to pressure and activated, and then they're ready to turn it over to the team in Houston, who will manage the spacecraft. Keep in mind that the way that this system works is we've got the spacecraft managed from Houston in flight, and then of course the launch vehicle is activated and run in Florida until we hit the point of launch. At 4 hours before launch, again, we're going to hand over to Houston. A little bit different than Shuttle and Artemis. We manage a lot of the last activities as far as commanding to the spacecraft, actually from Houston. There's also, besides that Boeing team in Houston and Florida, we also have a small team in Denver that works for United Launch Alliance that handles what gives me some information on what the rocket is going to be doing during flight. So we're all coordinating. The crew arrives at the pad 2 hours and 50 minutes before launch. They'll go up to the white room. You'll see the pad techs help them strap in. That process takes a little bit over an hour. They'll start closing the hatch at 1 hour and 20 minutes before flight. I should note too that the rocket is actually fully fueled before the crew gets out there. So that's one of the last things we do, is we load the rocket with the cryogenic propulsion while we suit up the crew. Again, we're at an hour and 20 before launch. We'll get the crew in, and then get the hatch closed. We'll do a leak check on the spacecraft, and the pad team will clear the pad about 50 minutes before launch. Okay, the real meat of the countdown, where you'll hear a lot of things on the audio that they provide. That's at L-18 minutes, we'll begin the transfer to internal power. That's where we go from the external power to the onboard batteries. That's commanded from Houston. You'll hear some comm checks between the crew and the ULA launch conductor, Doug Lebo. A number of polls going through the count, and then in the final 4 minutes, you'll hear the launch conductor give the crew an instruction to do a switch throw. It's called last arm to auto. That's last is the launch abort system. The crew will arm the abort system at 75 seconds, and then they'll go ahead and launch. Okay, so it's already been a busy day, but now we have liftoff. So that's where my real work starts. This is going to be the first crewed ascent that's been flown out of Mission Control in Houston since the STS-135 in 2011. Can we go ahead and roll the first video? I'll just talk for about a minute and a half through the ascent activities on the Atlas V. the animation, ascent. Okay. Again, we've got the Atlas V on the pad. Crew access arms retracted at 11 minutes, by the way. So there's liftoff from pad 41. Okay, on the Atlas V, most of your energy to make orbit actually comes from the first stage with those two SRBs and the RD 180 engine. Actually, one of the first things you'll hear from the crew here is roll program while we're going through ascent. Looking forward to hearing Butch talk to us right off the pad. Again, RD 180's got two engine bells. That's actually a single engine there in the first stage. First stage will burn, the SRBs will burn for about a minute and a half. You'll see them burn out. We actually carry the empty casings for another minute. It goes a little faster on the video, but we got to get above the atmosphere to jettison them. We'll get through first stage at 4.5 minutes. There's about a 15-second pause. As first stage separates, that's the ascent cover. That covers the docking system. It'll be jettisoned, and the aero skirt will jettison as well. And then the two RL-10s on the Centaur will take us on a nice, easy cruise to space. That'll take us up to about 12 minutes into the mission. MECO is 12 minutes. We'll stay on the booster for about 3 minutes, and then we'll have separation at 15 minutes into the mission. Again, we're suborbital still here. We got to do another burn. Starliner's actually got a pretty spectacular orbital maneuvering system. You'll see the 4 engines kick in there. We'll do that at 31 minutes into the mission, and that'll push the crew into orbit and get them heading on to rendezvous. Okay, so with that, as in the real world, we do one more burn at 1 hour and 15 minutes, but then I hand it over to Ed and his rendezvous team.
All right, thanks, Mike. My name's Ed Van Cise, and I've been a flight director since class of 2009, certified in 2010, so like Mike, about 14 or 15 years as a flight director. Experience International Space Station, Artemis 1 a little bit, Gateway flight director for about a year, lots of projects inside the space station. And then I've been working Starliner since 2016, so really all three of us up here have maybe different exact projects that we've worked on, but we all have significant experience across multiple programs for the agency, and also been working Starliner for quite some time. It's been really an honor and actually humbling to be able to work on Starliner from the days of when it was a PowerPoint presentation all the way up now to having 2 flights behind us and getting ready to go put crew into orbit on this 3rd flight. The teams that we get to work with are truly amazing and highly capable in everything that they do, and getting to be at the forefront of leading the teams, not just the flight controllers, but and the real-time engineering teams as well, but all the folks that are working in the factory and with ULA and all the other organizations we work with, and of course with NASA as well, and the Commercial Crew Program and the ISS program. Just having that capability and experience is just quite a pleasure. Like Mike said, we're getting ready to put this vehicle and this crew through a test flight and various phases of a test. So that's what you're going to hear a lot about as we are working through the missions. Obviously, the primary goal is to get the crew up to the space station and get them back home to the Southwest U.S. safely. But in that process, we are purposefully doing a lot of tests of the vehicle, as you would with the test flight of an aircraft or anything else. So you'll hear a lot about, from Vincent, you'll hear a lot about different test things that we're going to do while we're docked. But we also want to put the vehicle through some experiences that we don't anticipate being needed on a normal 6-month mission to the space station, but we know the vehicle should be capable of handling them if the crew are to need them. And so we want to check them out on this test flight as well, just to be able to say that yes, not only the normal mission will go fine, but then all of the capabilities the vehicle has on maybe not a good day, all of those work as well. So that's going to be the focus of the bulk of the crew's afternoon after launch. So they got up early, they went through everything that Mike just described. Now they're in space. They just completed the first co-elliptic burn, and you'd think that now it's just a great relaxing ride to the space station, and it will be for that 6-month increment mission. But like I said, we're putting the crew right to work, getting them out of their seats, out of their suits, and then right into some demonstrations. And we will be doing a bunch of things with the spacecraft to make sure that it can help the crew, and the crew can also maneuver the spacecraft as they need to. So we'll be doing things like purposefully pointing it in an orientation that's, say, not exactly the normal orientation for the mission, and then having the crew manually fly the spacecraft back into the direction it should be pointing. We also want to make sure that if for some reason the vehicle doesn't know where the communication satellites are located, that the crew can manually fly the spacecraft to point the antennas at the satellite. Another thing that we'll be doing this day is tricking, if you will, the spacecraft into thinking that it doesn't know where it is in space. So we're going to deallocate a couple of its inertial measurement systems to, they're still running, but the vehicle computers are not actually looking at them. So effectively the computers don't necessarily know where they are, and then the crew will manually fly the spacecraft to look at stars and use our star tracker to then rebuild its inertial navigation base. And we'll see how their manual way of doing it compares with what the still running computers are seeing, and see how well that compares. And they should all compare very equally, and we should be able to run off of that solution that the crew comes up with. But again, it's a test flight, so we want to see how well the vehicle does in all these scenarios that we've thoroughly tested out on the ground with all our avionics systems down here, but want to see how the spacecraft is really performing. And one other final thing that we'll be doing is we're putting all of our thrusters through a human manual flying checkout. So we want to make sure that not only can we point in space, but also can we do translations as well. So if we're close to the space station and the computers have a hard time controlling Starliner, we want to make sure the astronauts can manually fly away. And to ensure we have that capability, we're going to give the crew full manual control on this first day and just test everything out. So we'll do some demonstrations of that. And that last part is really important for the safety of the space station, so we have that manual capability. And we talked about the engineering teams that are here in Houston, the ones that are in Florida as well, and the other NASA programs involved. We're going to take a look at all this data while the crew's sleeping, and have the Boeing teams that we're embedded with will take a look at all that data, bring recommendations to our mission management team, and ultimately take that to NASA to certify that this manual flying capability is also something we're ready to use in proximity to the space station if we were to need it. So all that's happening while the crew's asleep, and then they'll wake up the next morning, and we can go ahead and show the video here for the free flight and the orbit. So this is kind of the end of the crew's day. This is the kind of representation of what they're doing at the in those tests that I was talking about. So we're pointing the nose towards the Earth, trying to see where we are with respect to the communication satellites. We also fly in this tail to the sun attitude, so our solar arrays are at the back of the Starliner, so we want to make sure we keep those pointed at the sun. But the crew's inside there, and they're getting ready for bed, and we'll do some more checkouts overnight while they're sleeping. They'll wake up in the morning. We'll be pretty close, a couple thousand kilometers away from ISS, and do a rendezvous that was exactly the same automated rendezvous we did for the last flight. We'll fly up underneath the space station and then around out in front, and we'll actually pause a little bit out in front of the space station, do some more manual flying, just to make sure that's exactly the way that the crew expects it. Then we'll press in, and at 10 meters, we'll do our final approach and dock, and then Sunny and Butch will get to get everything situated inside the cabin and get ready to come into their new home for the next few days. And Vincent's the expert on the space station side, so I'll hand it over to him to explain all that to you.
Thanks, Ed. So good afternoon, everybody. My name is Vincent LaCourt. I'm the lead International Space Station Flight Director for CFT. I was selected into the office in 2015. I'm going to walk through our dock time frame with the International Space Station. Our main goals of the dock mission are a few. There's to practice and validate the planned operations for long duration missions. We're also going to perform some contingency operations just in case we were ever to need those in contingencies, and then we'll do some cargo operations. Our lead planners, who are Richie Chantlos and Izzy Lasky, did a great job of trying to fit all the puzzle pieces together and have figured out that we can do our mission in a minimum of 8 dock days. So we have a few graphics I'm going to show you to kind of show you how the mission will look day by day. So the first of all, just as Mike said, we usually dock about 24 hours after launch. Once you arrive and dock to the space station, you're going to get, the crew is going to egress, get out of their ascent and entry suits. Then they're going to repress the vestibules and be able to open the hatches, and then they'll go on to the space station, and we'll have our welcome ceremony that you'll get to watch on NASA TV. Then the ISIS crew members conduct a safety briefing where they'll be able to take Butch and Sonny and remind them of where all the emergency hardware lives on the International Space Station in case we have any contingencies when they're on board. Now let's go ahead and go to flight day 3, which is dock day number 2. On this day, we're unloading all of the cargo, and we're also configuring the vehicle for quiescent operations. If you can imagine, when the Starliner is there for 6 months, you don't want to use all the power and leave all of your equipment running the whole time. So what the quiescent ops does is it basically powers off all the redundant equipment that you don't really need. The crew will still be able to go inside the capsule. They have good lights, good displays, good ventilation, things like that. But all of the extra computers and stuff like that will be powered off. We'll also get to do some emergency hardware transfer, getting ready again for some of the contingency operations that we're going to practice later in the mission. Let's go again to dock day number 3. On dock day number 3, we're going to do some of our operational checkouts. The first main one we're going to do is called our safe haven checkout. If you can imagine, if you have an emergency on ISS, you want to be able to get in your Earth return vehicle, isolate yourself, and make sure you're in a safe environment. So that's what we'll practice. Butch and Sonny will go into Starliner. They'll close the hatch. They'll basically completely power up the vehicle on their own to practice if they were getting ready for an emergency undock and return. So we'll basically make sure all that stuff works in a kind of a steady environment. On entry, we have a system called a sublimator that provides cooling for the vehicle that uses water. If for some reason there's any kind of leak or any kind of where we need additional water, we have the capability to refill that on board, even though you normally would not need to do that. So we'll get to practice that, again, just to make sure all the hardware connects correctly, make sure all the procedures are accurate, so that way if we need that in a contingency, we're ready for that. On the long duration mission, we'll have 4 crew members. And so what we'll do is we'll borrow a few ISIS crew members, have them float into Starliner with Butch and Sonny, and we'll practice that day of free flight to see how would we orient ourselves with 4 crew members. So we'll get to practice that before the long duration mission. And then we'll get to do a Boeing event where we'll have all of the engineers and employees who worked really hard to get Starliner on board. They'll get to interact with the crew and spend some time with them and see all that great hardware they built in space. We'll go to the next day, dock day number 4. So usually in the 6-month mission, 7 days before the mission ends, you'll take that quiescent config and do a complete power up and basically check out all the missions systems to make sure all the computers come on, make sure all the equipment is working. We're basically going to test that out on dock day number 4. Butch and Sonny will basically sit in the capsule and watch all of the displays and watch all the units come up, so that way they can understand how all the systems are working. Now let's go to flight day number 6, which is dock day number 5. We put this sample day in there. As Mike said, orbital dynamics will really drive what day we're able to undock. So if it's longer than an 8-day mission, this is one of the days we'll put in. So we'll give the crew a half day off. Again, they're very busy on all these days, so they'll get a little bit of rest. We've also trained Butch and Sonny to be able to do basically all of the key International Space Station tasks that could exist for them. So they're ready for any preventive maintenance, corrective maintenance tasks, as well as a lot of science tasks. So we'll ask the Space Station program what extra activities are available, and Butch and Sonny will go back to their International Space Station lives on their previous missions and get to do some of those tasks that they remember doing. Let's go to dock day number 6. At this point, we're really now focused on the end of the mission. So we're going to load all the cargo that's going to come home on the Starliner and start some of that undock preparations. That emergency equipment that was in Starliner, we'll now take that out and put it back on the ISS where it lives. One of the other training simulations we fly on Starliner is on entry, it's all automated, but there is the capability that if needed, the crew can take manual control and fly an entry. For Butch, he's just going to practice that right before launch, so he doesn't need a lot of practice. But on the 6-month mission, you want the crew to be able to get in that simulator and really practice those entries to make sure they're ready in case they need it. We'll get to practice that on dock day number 6. Let's go to the next day. Now we'll really do a full undock power up, make sure the vehicle is completely ready. We're going to have a conference with the crew to walk through all of their flight test objectives, make sure they give us feedback, so that way if we need to adjust any procedures or adjust any hardware, we can do that before Starliner 1. And then we'll have our standard departure news conference. Then we go to our next day. What we did is we went ahead and put in a sleep shift day because, again, because of order dynamics, you don't always get to undock at the same time of day. So this gives us a chance to sleep shift the crew for any time we need. And then we go to dock day number 9, which will be our last day on the International Space Station. We'll get to do our farewell TV events. The crew will get in their ascent entry suit. We'll close the hatch, and then we'll get ready to leave. And at this point, we'll hand back over to Mike, who will kind of walk you through the operations of how you undock and how you entry and land.
Okay, thank you, Vincent. So again, we mentioned where we are now is we're on undocking day and the crew is in the vehicle. I'll show a short video here in a second, but undocking happens about 6.5 hours prior to landing. That's a little bit longer on this test flight than it would be for a direct descent mission at the end of a 6-month increment. We added some time for the crew to do a couple more flight tests, and these are really important ones. Starliner is really unique in that it has a backup system. We call it a backup system where the crew, you know, they have a rotational and a translational hand controller, and they normally go through 3 flight computers that fly the vehicle automated. But as it turns out, we can have the crew engage backup control where they're actually firing, the commander can fire the jets directly bypassing the computers. And that's just designed so that if you had a really unlikely computer failure, the crew can actually manually control the vehicle in this backup mode by what I like to call stick and rudder flying. In fact, they can even deorbit and land in that mode. So what we're going to do is we're going to spend about an orbit with the Butch engaging the various, there's a couple of different jet manifolds that they can engage to get some experience flying in backup and just to make sure that get some feedback on how the vehicle flies with respect to all the experience that he has, both, you know, in our training sims on the ground and then, of course, the other spacecraft and even aircraft that he's flown before. So again, we'll go ahead and do that over a couple of revs. We do a deorbit burn, and you'll see this in the video, but we do a deorbit burn over the Pacific, and we target a landing in the southwest United States. We've got 3 landing areas. White Sands Missile Range in New Mexico. There's actually 2 spots that we can land there. It's a really quite a big place, and the other, and that's where the previous 2 Starliners have landed. There's also a landing area at Wilcox Playa. That's an area east of Tucson, Arizona. It's actually just off of I-10, or Dugway Proving Ground, which is west of Salt Lake City, and that gives us kind of a spread, geographical spread that allows us to get opportunities every day, depending on where orbital mechanics puts us. So we'll go ahead, we'll roll the video here. This is only about a minute, and then we'll be finished. Okay, so there's undocking. I think you'll see right after we undock, we back down the corridor. There's a cover that, this is a little early in the video, there's a cover that closes over the docking system. We fly a quarter lap, we go up over the zenith of ISS, and then we do a departure burn. I don't believe we show the deorbit burn here, but this is some of the tests that we're doing with the backup control that I mentioned. When we do the deorbit burn, it's pretty quick. It's less than a minute. And the deorbit burn will happen. The service module is separated. It does a disposal burn, and it burns up over the Pacific. The capsule will go ahead and do a guided deorbit using its own propulsion system, which was activated shortly before this. Landing sequence begins at 30,000 feet. There goes the forward heat shield, and then we put out a couple of drogues. You'll see those jettison here in a second. Hopefully we'll have video from the NASA WB-57 for this when it happens. Mains go out reefed at 8,000 feet, and then they'll disreef 3 mains. And it takes about, that's the bucket handle that gets us in the correct attitude for landing. We're on the mains for about 3 minutes. You should see here in a second the forward heat shield is dropped. And then the airbags deploy. And the crew touches down. And the crew will jettison the chutes manually. They do a switch throw that'll cause a lot of the vehicle systems to power down. Well, as they power down, we'll bring the crew up actually on a satellite phone. The landing team is 4 kilometers on an offset on the edge of something we call the 4-kilometer circle, just to make sure that they're safe from the falling parts that are coming off the vehicle. There are things like mortar lids and those drogues that you saw before. Once the vehicle's on the ground, that team will approach, and they're actually on the sat phone call with me and the crew, and we'll go ahead and turn the vehicle over once they're at the location, and then they'll go ahead and make sure that do the usual safety checks that you do around the capsule, and they'll take the crew out, they'll do the medical checks, and then the crew will be helicoptered to a landing field, and then they'll be flown back to Houston. So that is the mission summary.
Great, thank you so much. That was a huge wealth of information. Thank you to all of our briefers for that in-depth going over of the timeline. We're going to switch over to some questions now. We're going to be taking questions here in the room, so if you have one, go ahead and raise your hand. We'll also be taking questions on our phone bridge, so if you are on the phone, go ahead and press *1 if you've got a question for one of our briefers. Again, please state your name, affiliation, and who you'd like to address your question to. We can go ahead and start right here in the room.
Hey, Mike Maidberg, Wall Street Journal. Not sure who this would go to. Steve and Mark talked a little bit earlier about how Boeing is using NASA flight ops for this mission. First of all, just to be crystal clear, that's you guys, that's your teams. And then second, could you talk a little bit about decision making during the mission, if there is an anomaly, given NASA flight ops role and Boeing's like ultimate responsibility and authority and management over CFD? How does decision making work and something goes wrong? Thanks.
Sure. I'll take a little bit of that, but I'll also let Vincent weigh in too. So what you really have up here, you have 3 members of the Johnson Space Center Flight Operations Directorate that are NASA civil servants. But what you also have up here are 2 Starliner mission operations flight directors that are operating out of the White Flight Control Room, embedded with Boeing for design, development, test, flight, mission execution of Starliner. And you have 1 space station flight director. He's running his flight. Vincent's running his team down in Flight Control Room 1. Just like Space Station, 24/7, 365 is being run from there. And his focus and his responsibilities are for the safety and protection of the space station and execution of the entire NASA mission. So I'll let him go into details on that. Versus our side of things is focused on the crew safety, vehicle safety, mission success of the Starliner mission for and with Boeing. But also, of course, since we are providing a service to NASA and the Commercial Crew Program, primary focus for us too is, of course, safety and mission success for the space station. So it is a partnership with Vincent and his team and NASA and the ISS team, but there are some pretty clear distinctions. So we have, for those of you familiar with our operational products, we have flight rules, we have launch commit criteria that are Boeing products that tell us the limitations, the go, no-goes, things like that for Starliner that are part of Boeing process. We work on developing those with our mission operations flight control teams, the mission engineer, or the Boeing engineers, and then the Boeing management, so Mark and Leroy that you talked with earlier, and we get all those approved so that we know how to go operate in the Starliner spacecraft at the nitty-gritty level. But we also then work with Commercial Crew Program and ISS to ensure that what we're doing is within the requirements and safety paradigm of what NASA needs for really taking care of their astronauts, even though they're our friends. They're the NASA astronauts. We need to take good care of them. So that it is a collaboration, but there's still a distinction on the extent to which we're embedded within Boeing and their design and development and test versus Vincent's role.
Yeah, so I think from the International Space Station Flight Director role, it's very similar to how we do SpaceX, right? Once we get inside integrated operations, the International Space Station Flight Director has operational authority, and they're making the ultimate calls on, again, being go to dock, go to undock, those kind of decisions. The same way we would work with a SpaceX mission director, because they are the experts in the SpaceX capsule, the same way I'd work with Ed and Mike, that they're the expert in the Starliner capsule. So if there's any anomalies on the Starliner vehicle, again, my team is not the expert. We will listen to them and get their advice, and then we have space station flight rules where we document if they have failure of X computer, are we still go or we not go based on what redundancy and what risk we will take. So again, in a lot of ways for us, we've practiced this for years, but it's very similar to how we do other vehicles where, again, my job is to make sure the ISS is in the right configuration for docking, make sure all of our systems are at the right redundancies, and then to communicate with Ed, Mike, Chloe and Rick on their side to make sure that I understand the situation and what their vehicle is doing. And again, the good news for us is we sit right down the hall from each other, right? So off console, it's very easy to work together and get good situation awareness on anything they're working. So that's the benefit, right, of working at Johnson Space Center, where Boeing has contracted NASA to fly their vehicle. It's sometimes easier to be on the same page because we do work at the same place and see each other all the time.
Great, thank you. We'll take a question on the phone real quick. Marcia Dunn with the Associated Press.
Hi, I'm wondering how long could the Starliner and its crew stay at the space station if something goes amiss during ascent in the initial part of the flight? Are you taking up extra rations just in case? And is Boeing NASA working with SpaceX to be on emergency standby just in case? I'm just wondering the backup plans. Thanks.
I can go to answer first, like the cargo. So we have, we basically bring a lot of supplies for the crew for kind of that initial mission. We have some extended supplies in case they stay, but obviously ISS has plenty of food and water, for example. So really we're prepared for them to stay as long as they need to. Obviously there's certain weather requirements that we need to meet on CFT, and so we have no issues if we need to stay any longer.
Yep. As far as duration goes, there's really no hard constraint on the vehicle. This is the spacecraft that's designed to stay at space station for 6 months, and there's nothing essentially limiting that if you needed to. As far as being on standby, those are, I'm not aware of any of that.
Okay, we're going to go to a question in the room. Go ahead.
Hi, Elizabeth Howell from space.com. This is probably for Ed. So can you talk about during the close proximity operations to the ISS, aside from obviously the flight activities, the flight test activities that Sunny and Butch are doing, are there any key differences with how a SpaceX Dragon close proximity operations goes?
So I'm first going to admit that I've been focused on Starliner for a long time and have not been a NASA flight director for a Crew Dragon mission. So I don't have tremendous depth of detail to really give you a point-by-point comparison. But I have worked a couple of Dragon cargo missions in previous years. So at a high level, the trajectories are basically the same, largely because of what Vincent described with the way that ISS wants to have vehicles approaching and the way they want to manage the traffic plans. So at a very high level, all the spacecraft that come up to the ISS are going to come up from below and behind and then do some sort of rendezvous. If you're docking to the forward part of ISS, obviously you'll go below, behind, and front, and then kind of come up. The way that we do that with Starliner is a little bit different than with the Dragon. So the profiles will look a little bit different just because the sensors that we use, the sensor suites for rendezvous, are all different technologies, different way of doing things, different mission rules, different waypoints, if you will, to get on that trajectory. The way that the space station is monitoring the approaching vehicle is very similar. It's obviously not exactly the same, but it's very similar. And then largely, from that level, I can say that it's pretty close to the same. I can't really do a good comparison for you on timeline of events or the manual capabilities and the manual actions that crews might be doing. But from that perspective, it's pretty similar.
We'll take another question in the room.
Hi, Irene Klotz with Aviation Week for Mike. Two questions. The first one is, considering the redundancy in Starliner, do all systems need to be operational to meet the launch commit criteria, or are you able to fly if something is not operational? You can provide any detail on that. And then the second, just to clarify again the relationship between Boeing and NASA for the Starliner missions, for all intents and purposes, are you all sort of on leave from NASA on your official jobs and working as subcontractors to Boeing? So Boeing is your customer during these missions. You're no longer sort of representing NASA as you would if it wasn't a Starliner mission going on. Thanks.
Yeah, good questions. I'll take your second question first, because maybe here's another way of thinking about it. And I realize that it can be it's challenging to describe sometimes the relationship, but I'll give it to you another way. When I'm working Starliner, right, Ed and I, we actually have a charge code, right, and that is funded by Boeing. I mean, ultimately it's part of a NASA contract. But it's being managed by Boeing, and we're providing them service, right? And then that goes into even how the mission is run. When I report to the mission management team is chaired by Leroy Kane, who's a Boeing employee. Boeing runs the mission until we get into the joint ops with Vincent, as he described. Then NASA's got an oversight role like they do for all of the vehicles, but once, if we're outside of this area around ISS, it's a Boeing-run mission that is done in partnership with their customer, who is NASA. As far as the launch commit criteria, there's kind of two sets. There's the ones that ULA has, United Launch Alliance, and the Atlas V. I'm not as familiar with those, except to say that they do their own set of checks that's identical to all the commercial and government missions that they do for the rocket. For the spacecraft, in general, all the systems have to be up and running. I think I could probably get into some details where there's some small things that we can fly without. I was just talking yesterday about one criteria is how many, the crew uses tablets for their procedures, right? And we fly with 4 of them. Well, if something happened to one of them, we can fly with 3. So there's a few places where there's sufficient redundant systems you can go ahead and launch. But in general, all the flight computers, all the IMUs have to be running to launch. And we're evaluating those right down to liftoff.
Thank you, Mike. We're going to switch to a question on our phone bridge. Jeff Faust with Space News.
Mike, one, is there anything like the dry dress rehearsal that SpaceX does for Crew Dragon missions for Starliner? And then you mentioned the timeline for undocking to landing is a little bit longer on CFT versus an operational mission. What would be the time from undocking to landing for an operational mission? Thanks.
Let's see. For the dry dress, the answer is yes. There is an activity, and I forget the exact date right now, but it's about 8 days before launch, 7 or 8 days before launch, and it's called the crew training activity. It's really a full-up run where the crew, we have the whole team there. The crew suits up in the suit room. They get in the suits. We take them down to the spacecraft. The one difference is the spacecraft and the rocket aren't at the pad. They're in the VIF, the integration building. But we have them practice out in the pad white room on some other activities. But the crew will get into the spacecraft. The spacecraft is going to be powered. In fact, we're commanding it from Houston, just as we would on launch day, and we go through the entire launch count, including things like having the crew do suit checks, working with the pad team. We'll do all of that and get a chance to practice it. So that is being done and is similar. It is a dry dress. Let's see, the second question was the amount of time for a post-certification mission, as we call it, when Starliner is coming down. It would be the shortest possible time to get from undock to landing would be about 4 hours. There's a little bit of a dependency on whether or not there's a fly around done. So Starliner's got the capability to do a full fly around of the entire space station, to do photography of space station. We're not doing that on this mission. Potential to do it on the next mission if NASA requests it, and if they do, it'd be, I think, closer to the 6 hours.
Thank you. I've got a question right here in the front.
Gina Sinceri, ABC News for Matt. What are the weather and lighting constraints for landing?
Was that, so the question was weather and lighting constraints? The weather constraints for landing are, we essentially want the lowest wind that we can to undock, and then that's just to give a gentler, not have a large lateral component when we hit the ground. Also, we do things like we account for if a parachute fails or an airbag fails, and so you tend to be a little bit more conservative. Right now, I think we want limits that are less than 10 knots for that, and that kind of ties into the second part of your question, which was lighting. There are no requirements for lighting. In fact, we tend to like to land at night, and that's because two reasons. One is the wind is lower at night in the places that we're landing. Also, you got to think about the safety of the people that go out and meet the spacecraft after it lands. Some of them are in things called scape suits, which are to protect them if there's a leak of fuel or oxidizer from the vehicle. They're actually pretty hot, and we land in the desert, and so it's a lot easier on the landing team to land at night. And it turns out we found in previous missions, it's actually when I started working this program years ago, we were a little bit worried about operating at night, but they've actually come up with a really nice setup with the lights, and of course, if you see the video, we've got the infrared tracking, both from the ground and the aircraft. It's kind of funny. We've gotten to the point where we almost prefer the night. So.
Okay, we've got another question right here.
Horowitz, CBS. Well, we prefer the daytime, but that's okay.
It is prettier. Yeah. I will give you that.
Two quick ones from me, and I know this isn't a Dragon briefing. Obviously, it's Starliner. But are there any things in your minds that are clear advantages that Starliner brings to the table? Things that you particularly appreciate in terms of how it flies and how you control the spacecraft, how the crew does that? And secondly, do any of you have any idea what sort of TV we can expect from the mission between launch and docking? I know what we get on once it's at station, but is there any live downlinks during the mission that you're aware of, or do they have the capability to do that? Thanks.
I haven't talked lately. For the second question, there is, with the current Starliner for CFT, there is not the capability to do live video downlink. We do have the camera system that you saw on the last flight that'll provide streaming video when we're docked to the space station, and that camera system is running during the free flight phases as well. And the crew will actually be conducting some public affair events during free flight on both the first and second day of the mission, but they'll be recorded on the video system and then played back after we've docked. So there might be some audio of that comes down live, but for this flight, there's no live TV capability in the free flight phase. Comparing capabilities between Dragon and Starliner, again, I have to plead a little bit of Dragon lack of knowledge, just because I haven't really worked in depth on those vehicles to really give a good comparison. But I can tell you that they are different. And some obvious differences are the fact that Starliner lands on the land versus in the ocean. Starliner has tactile hand controllers for manual flying, whereas Dragon doesn't. And those are kind of some of the more obvious aspects, and they're just differences. They're not, one's not really better than the other, one's not necessarily more capable than the other, but they are different capabilities. The rendezvous sensor suite is different between the two vehicles. Just the way that the two companies have approached how they want to approach and depart from space station are also differences, and that then factors into how you train the crews, what you focus on with the crew training. And that really rolls into exactly what NASA, of course, wanted with the commercial crew program. Is you didn't want just one spacecraft or one provider that all your eggs are in that basket. You provide a couple of different capability from a access to space perspective, but you also provide a couple of different venues for industry to design solutions in their own way, using their own ideas that are different from each other, and you start to have this low Earth orbit economy that NASA has been talking a lot about, where now you have different options if you want to get a ride into space. So we are definitely going to be exercising those that Starliner has as much as we can, and then maybe the best way to answer your question is going to be after the mission, when the services that are looking to provide access to low Earth orbit can then compare between the two and see which of the two menu options, if you will, for accessing space are to their liking and meet their mission needs.
Thank you, Ed. We do look forward to seeing those live downlinks once they get to the space station. We have a question here in the room, in the back.
Thank you, Stephen Clark, Ars Technica. Just to follow up on Bill's question, what is the vehicle lacking on this particular flight that doesn't allow you to do the live video downlink, and will that come online like with Starliner 1? And secondly, my main question, Mike, can you talk about the abort modes during ascent? Can you walk me through different abort phases, different types of aborts you would conduct if you have to, hopefully not, at different stages? Thanks.
I can answer the first part, and then I'll let Mike do your part. Really, the only thing that the system is lacking is just connection from the video recorder to a transmission system. So the transmission antennas and the ground stations to receive those transmissions are just not online yet. So the capability within the capsule, the infrastructure for it is all there. We just haven't progressed enough into getting the operational post-certification piece to where we have that capability yet.
To answer the second part of the question, the aborts, so we spent a lot of time working on aborts. Boeing and United Launch Alliance have spent a great deal of effort making a safe system. The way aborts work is it's kind of joint between the spacecraft and the launch vehicle. The launch vehicle is monitoring itself, and if it needs to abort, it will tell the Starliner to abort. Additionally, we've got I've got a team of United Launch Alliance flight controllers that are actually in Denver, and they're reporting to me in real time. And they will tell me if they see an abort approaching, and we can do some things like perhaps abort early if we need to, just to put the crew in better weather over the ocean. It's a very large swath of the world we're flying over. But what you'll hear is at liftoff, as I mentioned earlier, the abort system goes active 75 seconds before launch. And then as we lift off and you gain more energy, you land at different places, right? So you'll hear them call the abort boundaries. One of them is CM forward, and that's just has to do with how how the service module is jettisoned after an abort, but that's still in the pad area around Florida. As you get more energy, right when the first stage goes at 4.5 minutes, you'll hear ECAL. That's East Coast Abort Landing. It's a heritage term. You actually end up in the ocean, generally east of Cape Cod. And then as you gain more energy, you will hear a call for St. John's, and that is in the area of the ocean near St. John's, Newfoundland. You'll do a guided landing there. And then once you have enough energy to get up over the North Atlantic, which is by design, vehicles designed to avoid that, you'll hear Shannon, and that's your Shannon, Ireland. And then once you obtain enough energy to make orbit, we've actually got a mode called ATO, or abort to orbit, and that'll get the Starliner, if there's a low performance case, the Starliner can burn its own engines and get into a low orbit that's 200 kilometers high. And actually, in a lot of cases, we can, given a little bit of time, we can actually figure out how to get a rendezvous out of that if we need to. But those are the kind of the top level how abort modes work.
So I want to go to our phone bridge because I know we don't have all that much time left. We'll go to Robert Perlman with Collect Space.
Great, thank you. 2 questions. Given the flight rate, is there just one NASA team assigned to Boeing for all of the Starliner flights in terms of mission control, or are there different assignments of different people assigned as you progress from CFT to Starliner 1? And a quick second question, in terms of referring to the vehicle on orbit, since there is a name of this spacecraft, Calypso, will NCC be referring to it as Calypso or as Starliner as you call back and forth from space to ground?
I'll get the first one. So I'll get them both. Hey, the first question, as far as the NASA team that supports Starliner, this is a really good question, actually, because you talk about the flight rate. And Starliner is kind of interesting in that, Boeing flies this crewed mission, and the team that we use, we have a very small core group of people that work this full time, but actually most of the team that flies this vehicle does other things, right? Both Ed and I do space station shifts, and we've done Artemis shifts, and it actually really helps with this flight rate, because I'm a guy that does operations. One of the things that's really important for people that does the kind of work that we do is you got to fly things, right? And it's all about how often you get to fly things. And that really builds a team that knows how to manage a spacecraft in space and do it safely. And the way this works out is that we can almost ebb and flow on this program as we're needed, right? So right now we're coming up to a flight and we surge. When you get into some of the time in between these year-long missions, we can allocate people to do other things, and that ultimately, saves resources as far as having a team that otherwise you'd need to have completely stood up to cover, 24/7 ops of a spacecraft that is free flying only a very short period of time. As far as the naming, what we've been using in all of our simulations is Starliner. That's kind of what we're used to and what we've been training. So I'm sure the name that Sonny used will come up, but in general in our training we've been using Starliner, and I expect that's generally what you'll hear.
Great. So we only have a couple of minutes left, but I do want to get one more question in the room, if it could be a quick one.
Yeah, hopefully this will be brief. Will Robinson Smith for Spaceflight Now for Mike. Assuming that the airbags deploy as nominally, can you describe what the impact the Butch and Sonny will feel like, what that sensation will be, and if one of them only partially inflates or doesn't fully inflate, what the difference for that might be? Thanks.
That'd be an excellent question for Butch and Sonny this afternoon, because they have both landed in, Butch has landed in a Soyuz, which has got an interesting way of landing, as we've seen. They land on land too, and but they're using rockets instead of airbags. But I believe the descent rate is about 25 feet per second. I would say that it's likely a firm landing, but you know, the requirements for these vehicles, that both the NASA crewed vehicles, as far as the conditions that the crew see at impact, is fairly gentle. It's not going to be, I think, something that puts the crew at risk in any way. And that includes with an airbag out, right? All those requirements, we call them the health and human performance requirements, but they were all there, and the vehicle is certified to do all these things, even with an airbag out. And that was part of the requirements to build it. So I suspect it's going to be pretty gentle.
Great. Thank you so much. That is all of the time that we have today. Thank you to our awesome briefers for talking about an overview of NASA's Boeing Crew Flight Test mission. As Mike alluded to, be sure to come back at 1 p.m. Central Time, 2 p.m. Eastern, because next we're going to hear from the crew, NASA astronauts Butch Wilmore and Sunny Williams. We'll see you then.
It's a new era of pioneers, star sailors, thinkers, and adventurers.
3, 2, 1, 0, all engine running.